Hello students, I am Kinjal Parmar. Welcome back to the video lecture series of microprocessor and microcontroller. Today we will discuss AVR branch instructions. So let's start with what is branch instructions. This AVR branch instructions is basically a jump instructions in which control of program is transferred either unconditionally or conditionally to the target locations. This branch instructions basically perform a jump to the desired locations either unconditionally, that means either depends on some conditions or it doesn't depends on any condition, and transfer the control of program. That means at another location there is some program and that program is going to be executed after this branch instructions. This in AVR there are two types of branch instructions, that is unconditional branch instructions and conditional branch instructions. So let's discuss this two branch instructions briefly. Here we have a first unconditional branch instructions. This unconditional branch is a jump in which control of program is transferred unconditionally to the target locations. This unconditional branch instruction is executed whenever it is written in a program, and always it transferred or always it jump to the desired location, as there is no such conditions over here. That's why it is known as a unconditional branch instructions. Unconditional branch performs a jump at a target locations. That means at that location there is some another program is stored. So if we are going to execute some program and at that program we have some unconditional branch instructions, so after that branch instructions whatever the value of program counter is basically stored at other locations, and now the values of program counter is basically stored address of a targeted location. That means the address of at which we are going to jump, that means address at which some other program is stored for this jump. This unconditional branch in AVR, basically these three instructions, that is JMP jump, RJMP that is relative jump, IJMP that means indirect jump. So this unconditional branch instructions include this three instructions: JMP jump, RJMP relative jump, IJMP indirect jump. So let's discuss all three instructions one by one. So first we have a JMP branch instructions. JMP is an unconditional jump that can go to the any memory location in the 4M address space of the AVR. In this AVR there is a 4M space in a memory. So JMP is an unconditional branch that can jump and go to any memory location in the 4M address space of AVR. This jump instructions is basically a 4-byte instruction. That means total 4 byte, each byte contains 8 bits, so total 32-bit instructions, and this 32-bit instruction in which 10 bits are used for opcode, that means for JMP, and the other 22 bits represent 22-bit address of the target location. So this address of this targeted location can be of 22 bits. So this JMP is basically a 4-byte instruction in which 10 bytes are used for opcode and 22 bits are basically for address of a targeted locations. In this branch instructions, basically 22-bit target address allows a jump to 4M memory of a memory location from 0 to 3FFFF. So it can cover entire address space. So using this JMP instructions, we can jump in all over the memory location using this JMP instructions, as it allows 22-bit target locations. So in this target address, this memory locations can be covered starting from 0 to 3FFFF. So it can cover the entire address space for the jump. Okay, so this is JMP branch instruction. Now RJMP branch instructions, as in a AVR can have a ROM space of 8 MB, but some of AVR family members have only 4K to 32K on chip ROM. So every byte is precious in this AVR microcontroller. So for this reason, there is also an RJMP instruction, because in a JMP instruction it use 32 bits, that means total 4 bytes. So to save some bytes for this some AVR families, for this reason there is a RGMP instruction, that is relative jump instruction, which is a 2-byte instruction as opposed to a 4-byte JMP instruction. This RJMP instructions is basically can save some byte of a memory in a many application where ROM memory space is in a short supply. So this RJMP instruction can be used when there is some sort of bytes in a memory locations. This RJMP is a 2-byte, that means total 16-bit instructions. So the first 4 bits are for the opcode and the rest of lower 12 bit is a relative address of a target location. So RJMP is a 2-byte instructions. The first 4 bits are used for opcode and the rest 12 bits are used for address of a targeted locations. This RJMP instructions is basically have a relative address range starting from 000 to FFF, is divided into forward and backward jumps, that is within a -2048 plus 2047 word of a memory relative to address of a current program counter. So this relative jump is basically jump either in a negative directions, or we can say that either in a backward directions or in a forward directions. So whatever the content of program counters, so at this program counter work as a reference address, and in this RJMP, after the RJMP instructions, if we want to jump at a desired location, so add the value of that locations in a program counter. So at that locations, this program counter is going to execute the program. So this RJMP instructions can have a address range of 000 to FFF, and this divided in a forward and backward jump. This program counter is basically a reference address. Okay, so this is RJMP branch instruction. So in RJMP, if the jump is forward, then relative address is positive. If the jump is a forward, then relative address is positive. Jump is forward, that means if we are at a program counter 10 and if we want to jump at a location of a 1520, so the relative address is a positive because we are going to jump in a forward directions. And if jump is a backward, then the relative address is a negative. Backward, that means if we are at a program counter of 15 and we want to jump at a address of a 5 or address of a 6, that means we want to go or we want to jump in a backward directions. So then relative address may be in negative. So this RJMP instructions includes this kinds of conditional branch instructions. Okay, so in this regard, RJMP is like the conditional branch instructions. So this RJMP instructions is preferred over a JMP instructions because it takes less ROM space. Now next here we have a IJMP branch instructions in AVR. This IJMP is a 2-byte instructions. When the instruction executes, the program counter is loaded with the content of a a Z register. Indirect, that means there is no direct address given with this instructions. This IJMP, that means indirect jump, basically use a Z register, so it jumps to the address pointed by the Z register always. So this IJMP instruction is going to be executed according to the content of Z register, so it jumps to the address pointed by the Z register, and Z register, that means a content of R30 and R31, general purpose register R30 and R31. So in the other jump instructions, the target address is a static, that means in a specific conditions they jump to fixed point, but in this IJMP instructions, this is basically a dynamic target point instruction. So IJMP has a dynamic target point, and this can be dynamically changed the target address of by changing Z register's content through the program. So if the content of Z registers are changed, then the jump of this IJMP may include some other addresses. So that's why this IJMP is basically have a dynamic target point addresses. So these all are the unconditional branch instruction. Now let's discuss about conditional branch instructions. So here we have a conditional branch instruction, which is a jump in which control of program is transferred conditionally to the target location. The conditional branch instruction is a jump in which control of a program is transferred conditionally to the target locations. So that means whenever address is given, but at that address jump is executed if and only if some condition is fulfilled. That's why it is known as a conditional branch instruction. The conditional branches jump at other location at a targeted location if a certain condition is met. The conditional branches jump at other location only if certain condition is met. So all the conditional branches are short branches, that means short jump, as they are 2-byte instructions. The opcode is 9-bit and the relative address is 7-bit. 2-byte instruction, that means 16-bit. So for 16-bit, 9-bit is used for opcode, and for address we have a 7-bit in a AVR controller. So this conditional branch instructions are basically executed with this conditions of a various flag. In the AVR there are various conditional branch instructions depending on the various conditions of flag. If some condition of flags are met, then this instruction is executed, otherwise it fetches the next instructions of a program counter. So this conditional branch instruction is basically executed when certain conditions are met. If there is a no match of conditions, then next line is going to be executed. Now let's discuss all this unconditional and some conditional branch instructions. So here we have a table for branch and instructions. So first is unconditional instructions, that are JMP, IJMP and RGMP. So JMP K, that means direct jump. So whatever the value of K is directly copied into the program counter. So if the values are directly copied into the program counter, so at that locations whatever the content of program counter is, what is the main function of program counter? Program counter is execute the next instruction to be executed. So after the jump instruction, if the value of program counter is stored some other location, so at that locations our address are going to be stored, and at that locations our programs are going to be executed. So in this JMP K, whatever the content of K is directly copied into the program counter, and at that locations next program is going to be executed. Now next is RJMP, that means relative jump. Relative jump, so for relative jump program counter is is reference. So in a relative jump, value of the program counters are basically added with k. Okay, so in a program counter the values are program counter plus k plus 1. So whatever the value of k is added into the program counter. For example, if we are at an address of 10 and now we want to jump at a address location 15, so value of the k is basically 4. Okay, so program counter plus 4 plus 1, so at a 15 number locations we can jump. Okay, so it is not necessary to denote k is equals to 50 to jump that. If we use JMP instructions to jump at a 15 number address, so we can use JMP, but if we use 5 or 4 some to save some bits, so we can use this RGMP instructions. Okay, so program counter plus some minor changes plus 1, so using that we can jump at a desired location with less number of bits. Now IJMP instruction, so IJMP instruction, that means indirect jump to address given by Z, bracket Z, that means indirect jump to address given by Z. So whatever the content of Z is directly copied into the program counter, and program counter store next instruction to be executed. So using this, by changing the values of program counter, we can jump to the desired locations. Now this all are 3 are unconditional branch instructions. Now let's discuss about conditional branch instructions. So here first is a CPSE RD, R. So what it does, compare and skip if equal. Compare and skip if equal. So if RD is equals to R, then value of program counters are basically program counter plus 2 or 3, because 2 plus 3, that means it skip the next instruction. If we are executing a code line of 10, then 11 number line codes are skip and directly 12 or 13 depending on which instructions are executed and if some conditions are met. Okay, so if RD is equals to R, then the program counter is basically skip one line and then directly jump to the third or second or third number location. That's why compare and skip, that means if RD is equals to R, then program counter is equals to program counter 2 plus 3. Actually whatever the value of program counter is, after one execution there is a program counter plus 1, but if here there is a skip, that means next line is going to be skip and then next line is going to be executed. So this is the conditional branch instruction. If RD is equals to R, then and only then it skip, otherwise it is executed next line. Then SBRC RRB, that means skip if bit in a register is clear. Skip if bit in a register is clear. If in a R register B number of bit are equal to 0, then the value of program counter is going to be altered, that is program counter plus 2 plus 3. So if for given number of bit is cleared, given number of bit are equal to 0, then program counter is equals to program counter plus 2 or 3. Now next is SBRS, that means skip if bit in a register is set, that means B number of bit in a register is equals to 1, then program counter is equals to program counter plus 2 or 3. Now next is SBIC. So this is for port register, input output port. So this SBIC, P is for a port name, either A, B, C, D, and B is for a given number of bit. So skip if bit in a IO register is cleared. So here if P of B, that means if we use in port and if we are going to be checked for 4 number of bit. So if in a port A, if 4th number of bits are equal to 0, then we want to jump. So here if A of 4 is equals to 0, then program counter is equals to program counter plus 2 or 3. So skip if a bit in IO registers are cleared, and same for one SBISPB, that means skip if bit IO register is set. So if P of BR is equals to 1, then program counter is equals to 2 plus 3. If this condition is met, then and only then it jump or it skip the next instruction, otherwise it execute. Now next here there is other conditional instruction, that is BR, BS, SK. So branch if status flag set. So if shift register is equals to 1, then program counter K plus 1. So at a desired location this program counter is going to be jumped with targeted address. So branch if status flag set. So if shift register is equals to 1, then program counter is basically shifted or jumped at this location. Now if we want to jump when status register is clear, so this instruction is executed, that is BR, BC. So BR, BC, S, K, that means branch if this shift register equals to 0, then it will jump at a program counter K plus 1. Then next is a branch if equal. So here BREQ K. So branch if equal, this all are the basically kind of relative jump instruction. That's why this conditional branch instruction is known as a short branch instructions. That's why here we have a directly address of a K, and this address are basically added into the program counter. Then after that program counter work as a reference, and then this K value is added into the program counter, and then it jump at the target location. So first is a BREQ at K, that means branch at a K and add this value in a program counter if equal. So BREQ, branch if equal. So if we want to find the condition for equal, so if we check this Z flag, if numbers are equal, so result of A minus B equal to 0, that means 0 flag is set, right? Whenever two numbers are equal, the result is 0, and the result is 0, then 0 flag is set. Okay, so if 0 flag is set, Z is equals to 1, then branch. If 0 flag is equals to 1, so we can say that numbers are equal. So branch if equal, for that BREQ. So K. So branch if equal. So if Z is equals to 1, then program counter is equals to program counter plus K plus 1. Now branch if not equal. So if Z is equals to 0, then program counter is equals to program counter plus K plus 1. So branch if not equal, that means if the result of Z is equal to 0, that means A not equal to B. Okay, that's why it will jump. Now next is branch if carry set. So BRCS at a K locations. So branch if carry set, that means if C is equals to 1, then jump at this location. If then next is a BRCC, that means branch if carry clear. So if C is equals to 0, then jump at this location. Now next is BRSHK, that means branch if same or higher. So if A some numbers A greater than B, so at that location this C is equals to 0. Okay, so for same and higher, this C is equals to 0. So if C is equals to 0, then it will jump at this locations by changing values of program counter with program counter plus K plus 1. Now next branch instructions are BRLO, that means branch if lower. Branch if lower. So for lower, if C is equals to 1, then program counter is going to be altered with program counter plus K plus 1. Now next is BRMI, that is branch if minus. So to represent minus, if negative flag is set, that means number is negative. So if n is equals to 1, then jump at this location. And BRPL, that means branch if plus, that means there is a no negative number, no negative flag is set. So if n is equals to 0, then jump at this location. Now next is BRGE. Okay, so these are the four sign number branch if greater or equal. So to calculate greater or equal, we have a negative and V flag. So if n and V both are 0, then it will jump at that locations. And if branch if less than 0 for a sign number, then if less than 0, that means negative. Okay, and less than, that means V flag is set. So if n and V V are equal to 1, then it jump at this location, program counter plus K plus 1. Now BRHS, that means branch if carry half carry flag set, that means if H is equals to 1, then jump at this location, and if half carry flag is clear, that for that BRHC. So if H is equals to 0, then jump at this locations. Now next branch instructions are for this BRTS, that means branch if T flag is set. So if T is equals to 1, then jump at this location. Then BRTC, branch if T flag is clear. So if T is equals to 0, program counter is basically program counter plus K plus 1. Now we have a next, that is BRVS and BRVC for branch if overflow flag is set, branch if overflow flag is clear. So if V is equals to 1, then jump at that location, and if V is equals to 0, then jump at that location. So this is for overflow flag. Now this next is BRIE for interrupt enabled flag. So BRIE, that means branch if interrupt enabled, that means if I is equals to 1, then jump. And next is BRID, that means branch if interrupt enable is disabled, that means if I is equals to 0, then jump at that locations. So this all are the branch instructions. There are two types of branch instruction, that is unconditional and conditionals, and these all are the conditional branch instruction, in which if the some status register bits are set or clear, depending on that this jump are going to be executed. Otherwise it will fetch the next instructions which are going to be executed. Thank you.